Yesterday we learned about factorials. What does factorial mean? If I say 7 factorial, what does that mean? 7 times 6 times 5 times 4, 3, 2, 1, all the way down to 1, right? Then we learned the permutation formula. Let me write NPR. What does N mean or represent?
The number of things, like letters.
N is the number of objects, and R is the number that you're picking. Like if I have 8 objects and I have to pick 4 of them, right? So if I said, what's a word? Can't even think of a word right now.
Victoria.
10 different colored toys.
No, stupid.
Isn't that what we're doing?
Okay, let's just do
Canary.
What's the P for?
10 different colored pens. We'll just do 10 pens. I know. I don't know why
So many
this.
things.
Okay, 10 pens. All right, and I want to pick 4. Then you would go pick 4. You would go 10 P4. And that's the same as saying, okay, if I want to pick 10 pens, I have 4 spots. I have 4 choices or 10 choices for the first one, and then 9, and then 8, and then 7. They mean the same thing. That's what we're going to learn today. All right. So that's the stuff we learned yesterday. We didn't have any restrictions. We didn't have any repeats. Today we're going to learn about if we have restrictions and if we have repeats. So we'll start with the word oranges. How many ways can I arrange all the letters in the word orange? Oranges.
5,040.
So how many letters are there? There's 7. So you could go 7 choices, 6 choices, 5, 4, 3, 2, 1, which is just 7 factorial. Or you could go, there's 7 letters. I have to pick 7 of them, and that's going to give me 7 factorial again.
You just do 7 factorial?
Yeah.
You don't have to do 7P, 7.
Nope, you can do them. There's a few different ways to do them. It's your choice. So 5,040 ways. Now, what if I force you to make the first letter an N? So if that's an N, there's only one N. So you have one choice. How many letters are left now?
6.
6. So then it's 6, 5, 4, 3, 2, 1, which is really just 6 factorial. So that drops it to 720. So as soon as you make one restriction of one letter, we drop from 5,000 ways to do it to 720 ways. What if I then say the vowels must be together and in the order O-A-E? So if I force you to put letters together in a specific order, it helps to think of it as one letter, essentially, or one sort of object. So O-A-E. There's only one way I can arrange them, right? It has to be in that. So one way. How many letters are left once I remove the O-A and E? There's 4 letters. So how many choices do you have for the next letter? 4. And then 3, 2, 1. So that's 4 factorial, right? So 1 times 4 factorial. But did I say O-A and E has to be at the beginning? So it could be in anywhere. How many spots are there for it to be in? 5. So you'd multiply by 5.
So it's 5 factorial.
So that's really just 5 factorial. Yeah, this is 5 factorial. And that gives you 120. So again, we dropped to 120 just by making another level of restriction. Okay, so in that one, I said OA and E has to be together in that order. What if I don't do that? But they have to be together, but they don't have to be together in that particular order. So the word brains. How many letters are in the word brains? 5 letters. 6 letters, sorry. 6 letters. How many vowels are there in that word? 2. A and I. The vowels need to be together. So I treat them as one. Okay. Now, does it have to be A and I? Or could it be I and A? Could be I and A as well, right? So that means there's two ways to arrange those letters. It could be AI or IA. How many choices now do I have for the next letter? In this spot right here.
How many letters are there total again?
So
6.
There's 4 ways.
So there's 4 ways, right? So then 4, 3, 2, 1. Does the A and I have to be at the beginning?
No.
No. So what do I have to multiply by?
5.
5, right? Because there's 5 different spots. 1, 2, 3, 4, 5. No.
Yeah.
1, 2, 3, 4.
That last one is just.
The last one.
Oh, yeah. Okay, there we go. So there's 5 spots. So the answer is 2 times 4 factorial times 5. Whoa. Yeah. All right. There's a formula for this. If I force letters to be together but in any order. It's a homegrown formula. And the formula is number of letters restricted. So that would be the vowels in this case. Factorial. Okay? Because if it's 3 letters that I restrict, it can be, there's 6 ways to arrange those letters. 3, 2, 1. All right? Times the number of letters left. Number of letters. And it could be objects. I guess I should say objects, but whatever. Letters remaining. Factorial. Times the number of spots.
Is that not factorial?
No. Because the number of spots is the A and I could be here, 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 or here. So I just multiply by 5, right? So let's look at this first one here. K, C, and N in the word kitchen must be together, but not necessarily in that order. So how many letters am I forcing to be together? 3.
But they can be in any order, so that's 3 different ways.
No, it's not 3 different ways, it's 6 different ways. Because within the KCN, you have 3 choices, and then 2 choices, and then 1 choice. So that's 3 factorial.